What's up? I'm Vin, and I'm showing how to find polynomials with the same end behavior of rational functions. So for questions 1 through 3, I'm going to use long division to find the polynomial that has the same end behavior as the rational function, and then I'm going to verify the result using graphing technology. And the technology I'm going to use is desmos. Okay, that site is pretty good for getting graphs of functions. So what we have here is this rational function f of x. And what I'm going to do first is just expand the bottom. So we have minus x to the fourth plus 2x to the third minus 2x on top. And on bottom, we could expand x minus 1 squared. I'll just do this off to the side first. We have x minus 1 times x minus 1 is we have x squared. And then we have minus x. We have minus another x. And then negative 1 times negative 1 is positive 1. So the denominator I could write as x squared minus 2x plus 1, and now I'm just going to divide these two here. Okay, so I'm just going to make a little space, and we're going to do the division. We're going to do negative x to the fourth, so we're going to have negative x to the fourth plus 2x to the third. There's no x squared term, so I'm going to put plus 0x squared as a placeholder, and then I'm going to write minus 2x. And we're dividing this by, we have x squared minus 2x plus 1. So now we start the division and we're focusing on the leading terms. So I'm doing negative x to the fourth divided by x squared is negative x squared. And then we distribute. We have negative x squared times x squared is negative x to the fourth. And then we have negative x squared times negative 2x is positive 2x to the third. And then I do negative x squared times 1 is negative x squared. And I'm going to be subtracting this polynomial here from what's above. And what happens is the minus goes through and changes the signs of everything on the inside. So I'm just going to change the sign of everything. We have plus x to the fourth, minus 2x to the third, and then plus x squared. So these terms here are just going to cancel out. And then we have 0x squared plus x squared is x squared. And we start this process all over again. And I'm just going to bring down this minus 2x. But now when we start the process over, we're doing x squared divided by x squared is 1. So now I distribute. I have 1 times x squared is x squared. And then I have 1 times minus 2x is minus 2x. And then I have 1 times 1 is 1. And we're subtracting this here. So I could just change the sign of everything. And that's going to accomplish the same thing. So x squared minus x squared cancels. Negative 2x plus 2x cancels. And then we have minus 1 left on bottom. Okay, so we have negative x squared plus 1. And then I have minus 1 over. And we originally divided by x squared minus 2x plus 1. So now we could find the polynomial that has the same end behavior as this rational function. And it's just going to be the part here that's not left over. Okay, so we're just ignoring the remainder here. And this part, I could say y equals negative x squared plus 1. This polynomial is going to have the same end behavior of f of x over here. And the reasoning behind this, if I write f of x out, so we're saying f of x is equal to negative x squared plus 1, and then we have minus 1 over x squared minus 2x plus 1. And it's worth noting here that the domain of f of x is all x values except 1, because if we look at the original form of f of x, we just had a denominator of x minus 1 squared. But if we think about why this process works, and we're going to check it with desmos in a moment, but as x approaches infinity, okay, or minus infinity, the 1 over x squared minus 2x plus 1, this entire term here is going to shrink to 0. Okay, because we have 1 divided by, if I plug in plus or minus infinity, the denominator is just going to grow very, very, very large. Okay, and my thinking behind this is when we have a quadratic like this on bottom, a quadratic, when we have a positive x squared, is smiling at us. So as x approaches plus or minus infinity, the y value is going up to infinity. So I have 1 divided by a giant number, and this is just shrinking to 0. So that's why when we're looking for the polynomial that has the same end behavior, we could just focus on this part because, once again, as x goes to plus or minus infinity, this piece is shrinking to 0. So now let's take a look at f of x in desmos here. And remember, when we did the polynomial division, we had negative x squared plus 1, and then we had our remainder piece after. So if we just graph the polynomial part here, notice that as x goes all the way to the right, the blue graph is starting to get closer and closer and closer to the red graph. And as we go all the way to the left, once again, the blue graph is getting closer and closer and closer to the red graph. So this is telling us here that our polynomial with the same end behavior of f of x is negative x squared plus 1. Question 2, we're going to find the polynomial that has the same end behavior of g of x. And first, I'm going to find the domain of the function. We're just looking at when is the denominator equal to 0. The denominator equals 0 when x is negative 1. So our domain is all x values except negative 1. So now I'm going to do the division here. So we have x to the third minus 3x squared. There's no x term, so I'm going to put a plus 0x as a placeholder. And then we have plus 7. And from here, we're going to divide by x plus 1. So we're just going to focus on the leading terms here. So x to the third divided by x is x squared. And now we could distribute. X squared times x is x to the third. X squared times 1 is x squared. And we're going to subtract these two terms here. So I'm just going to change the signs of both like this. X to the third minus x to the third cancels. And then we have negative 3x squared minus x squared is minus 4x squared. We could bring down the 0x. And now we start the process over. We're doing negative 4x squared divided by x is minus 4x. And we multiply. Negative 4x times x is minus 4x squared. And then we have negative 4x times 1 is minus 4x. And from here, we're going to subtract these two, so we could just change the signs of both. And these terms are going to cancel. 0x plus 4x is 4x. And now we bring down that minus 7. So from here, we're doing 4x divided by x is 4. So we have plus 4. And now we have 4 times x is 4x. And we have 4 times 1 is 4. We're subtracting, so we're just going to change the signs of both. So now let's close this out. We have 4x minus 4x canceling. Negative 7 minus 4 is negative 11. And that's our remainder. So I'm writing minus 11 over x plus 1. So it looks like here our polynomial with the same end behavior of g of x is going to be x squared minus 4x plus 4. So I'm just going to write that over here. We have g of x. I'm going to rewrite it. I could actually factor this very nicely. So we're looking for two numbers with a sum of negative 4, and the two numbers have a product of positive 4. So something like x squared minus 4x plus 4, we could factor to x minus 2 times x minus 2. Okay, so this is just, we could express this as x minus 2 squared. So g of x, I'm just going to say is x minus 2 squared, and then minus 11 over x plus 1. And remember, the domain is all x values except negative 1. But the polynomial with the same end behavior is just referring to the part of the function where the remainder is not attached. So the polynomial with the same end behavior should be x minus 2 squared. But we will verify this result in Desmos. So here's a graph of g of x, and let's see what happens if we also graph y equals x minus 2 squared. Notice that as x goes to infinity, we could just focus on this part of the graph over here, that the graph in blue is getting closer and closer and closer to the graph in red. And as x goes to negative infinity, so if we zoom out here and then look at what happens on this side here as x goes to minus infinity, the graph in blue is still getting closer and closer and closer to the graph in red. So we can say that these two graphs have the same end behavior. As x goes to plus or minus infinity, both functions are going up to infinity. Question 3, our last question. We have the rational function h of x, and this time our denominator, we have something on bottom that is always positive. 2x squared plus 2 is always greater than 0. So we could say here the domain is all real numbers. Okay, we're not going to have any issues with division by 0. So our domain is all real numbers. But now watch what happens here when we do the polynomial division. We have x to the third plus 2x squared. We have no x term, so we could put a 0x as a placeholder. We have minus 5, and we're dividing by 2x squared plus 2. So from here, I'm just focusing on the leading terms, and x to the third divided by 2x squared is going to give us 1/2 x like this. Okay, so we have 1/2 x. And if we distribute, 1/2 x times 2x squared is going to give us x to the third power. And then we have 1/2 x times 2, and that's going to give us, we're going to have just 1x. But notice that this is going to go over here like this, okay? I'm going to put this next to the 0x term. And right now I have no x squared term that I'm subtracting. So I'm going to subtract all this stuff. We go minus, minus, minus. And these terms cancel. We have 2x squared minus 0x squared is 2x squared. And then we have 0x minus 1x is minus 1x. And now from here, what we're going to do is divide these leading terms. 2x squared divided by 2x squared is 1. So I'm going to write plus 1, and now we distribute. We have 1 times 2x squared is 2x squared, and then we have 1 times 2 is 2. But notice I could bring down the minus 5 at this step as well. And when I do 1 times 2, I'm just going to write plus 2 over here. And I also could say that I have 0x to subtract. So I'll just put that there as a placeholder. And now I'm subtracting everything. So I just put minuses all across. These terms cancel. I have I have negative x minus 0x is minus x. And then minus 5 minus 2 is going to give us minus 7. So I'm going to write, we're going to have plus, and then we have minus x minus 7 divided by 2x squared plus 2. But remember, when we're looking for the polynomial with the same end behavior, we have to look at the part that does not have the remainder attached. So that's going to be the 1/2 x plus 1. So when we're looking for that polynomial, it's going to be y equals 1/2 x plus 1. But now we will verify the result on Desmos. So now let's take a look at this graph of h of x and watch what happens when we graph y equals 1/2 x plus 1. As x goes to infinity, notice that our graph in red is getting closer and closer to the line in blue. And as we go all the way to the left here, as x goes to minus infinity, the graph in red is getting closer and closer to the line in blue. So we would call this a slant asymptote. So we could have asymptotes in the form of a line, a parabola, or higher polynomials. But these graphs, once again, will have the same end behavior. As x goes to infinity, both of these graphs are going to infinity. But now as x goes to minus infinity, both of them are dropping down to negative infinity. Okay, so as x goes to minus infinity, the y values are going down to minus infinity.